Good morning, my dear students of second secondary. I am Mr. Sharif and I'll be your math teacher for this year. Today's lesson is called Limits of the Function at a Point. Firstly, you should know how to get the limit of a polynomial function. For example, it is required to find the limit of the function 5x plus 1 when x tends to 2. Here, to get the limit, you should substitute by the given value of x. Then 5 is multiplied by the value of x, which equals 2. 5 multiplied by 2 plus 1, then the value of the limit equals 11. Another example, the limit of the polynomial function 2x squared plus 4 when x tends to 1. To get the limit, you should substitute firstly by the value of x. Then 2 multiplied by 1 raised to power 2 plus 4, the value of the limit here equals 6. Another example for a constant function, the limit of the constant function 5 when x tends to 3 equals the value of the constant function, which equals 5. Then you should know how to get the limit of algebraic fraction. For example, the algebraic fraction x squared minus 4 over x minus 2. It is required to find the limit of this function when x tends to 2. The first step, as we said before, you should substitute by the value of x in this function. Then 2 power 2 minus 4 over 2 minus 2, and this result will be equal 0 over 0. So this function has a limit. But you should firstly simplify the algebraic fraction to its simplest form to get this limit. Then, how can we simplify this algebraic expression? The numerator here is a difference between two squares. It can be factorized into two brackets. The square root of x power 2 can be written as x and x. The square root of 4 equals 2. Here also is 2. And the sign here is positive and here is negative. The denominator equals x minus 2. I'll cancel x minus 2 and x minus 2. The remainder is the expression x plus 2. Then the limit of this function when x tends to 2, I'll substitute by the value of x, which equals 2. Then 2 plus 2 equals 4. Therefore, the limit of the algebraic expression x squared minus 4 over x minus 2 equals 4. Again, we can see these steps here. The expression x squared minus 4 was factorized into two brackets x minus 2 and x plus 2. Then x minus 2 and x minus 2 is cancelled. The remainder is x plus 2. Then the final result of the limit equals 4. Another example. Find the limit of the algebraic expression x power 3 plus 27 over x plus 3 when x tends to negative 3. The first step, you should substitute by the value of x, which equals negative 3. Then negative 3 power 3 plus 27 over negative 3 plus 3. Then the result equals 0 over 0. So this algebraic fraction has a limit. But you should simplify this expression to its simplest form to find this limit. How can we simplify the numerator? The numerator here is a sum of two cubes. We can factorize this expression into two brackets, a small bracket and a large bracket. The terms of the small bracket, cubic root of x power 3 equals x, cubic root of 27 equals 3, and here is the sign, the same sign of the expression, plus. The terms of the large bracket, x power 2, here also 9. You should change this sign from positive to be negative and multiply these two terms, x multiplied by 3 equals 3x. The numerator here is x plus 3. I'll cancel x plus 3 and x plus 3. The remainder here is x squared minus 3x plus 9. Then the limit of the function when x tends to negative 3 of this expression, x squared minus 3x plus 9 equals negative 3 power 2 minus 3 multiplied by negative 3. I'll substitute by the value of x plus 9. And this value equals 27. Therefore, the limit of this algebraic fraction function equals 27. Here are the steps again. The expression of the sum of two cubes was factorized into the two brackets, x plus 3, x squared minus 3x plus 9 over x plus 3. The remainder is the expression of x squared minus 3x plus 9, and to get the limit, substitute by the value of x, which equals negative 3, to get the final result, which equals 27. Another example, limit when x tends to 2 of the function x minus 2 over x squared minus 5x plus 6. The first step, you should substitute by the value of x, which equals 2. Then the result will be 0 over 0. The numerator here is x minus 2. The denominator is the trinomial x squared minus 5x plus 6. This expression was factorized into two brackets, x minus 2 and x minus 3. Again, how can we factorize the denominator? Here, the numerator is x minus 2. The denominator can be factorized x squared to be x and x. By using your calculator, you can use the calculator to factorize this trinomial mode equation number 3, a equals 1, b equals negative 5, and c equals 6. The two values on the calculator are x equals 2 and x equals 3. X equals 2 can be written as x minus 2. X equals 3 can be written as x minus 3. Then I'll cancel x minus 2 and x minus 2. The remainder will be 1 over x minus 3. Here is the limit when x tends to 2 of the algebraic fraction 1 over x minus 3. To get the limit, I'll substitute by the value of x, which equals 2. 2 minus 3, 1 over 2 minus 3 equals 1 over negative 1, which equals negative 1. This is the value of the limit of the algebraic expression x minus 2 over x squared minus 5x plus 6. Here are the steps again. 1 over x minus 3 is the remainder, and 1 over negative 1, the final result equals negative 1. Another example of limit when x tends to 3 of the algebraic expression 2x squared minus 5x minus 3 over 2x squared minus 3x minus 9. By direct substitution with the value of x, then the numerator will be equals 0 and the denominator will be equals 0. 0 over 0 means that this algebraic expression has a limit, but you should simplify the algebraic fraction to get the limit. You should simplify this algebraic expression to its simplest form. You can use your scientific calculator to factorize the numerator and the denominator. Here, mood equation number 3, a equals 2, b equals negative 5, and c equals negative 3. The result, x equals 3 can be written as x minus 3, and x equals negative 1 over 2. And this value can be written as 2x plus 1. Again, the denominator, mood equation number 3, a equals 2, and b equals negative 3, and c equals negative 9. The two values of x given by your calculator, x equals 3, it can be written as x minus 3, x equals negative 3 over 2, and this value can be written as 2x plus 3. I'll cancel x minus 3 and x minus 3. The remainder is 2x plus 1 over 2x plus 3. Therefore, limit when x tends to 3 of 2x plus 1 over 2x plus 3 equals 2 multiplied by 3 plus 1 over 2 multiplied by 3 plus 3, and this value equals 7 over 9. The limit of this algebraic fraction equals 7 over 9. Here the steps again. The numerator was factorized into these two brackets, x minus 3, 2x plus 1. The denominator, x minus 3 and 2x plus 3. The remainder, 2x plus 1 over 2x plus 3. I'll substitute by the value of x, which equals 3, and the final result, the value of the limit equals 7 over 9. Another example. Here, limit when x tends to 2 of the algebraic fraction x power 3 minus 8 over 3x squared minus 12. The numerator is a difference between two cubes. It can be factorized to x minus 2, and the large bracket is x squared plus 2x plus 4. And the denominator, take care. To factorize the denominator, you should take care that 3 should be taken as a common factor. Then 3 multiplied by the remainder is x squared minus 4. X squared minus 4 is a difference between two squares, and it can be factorized into the two brackets, x plus 2 and x minus 2. I'll cancel x minus 2 and x minus 2. The remainder here, I'll cancel x minus 2 and x minus 2. The remainder here is x squared plus 2x plus 4 over 3 multiplied by x plus 2. To get the limit, substitute by the value of x, which equals 2 power 2 plus 2 multiplied by 2 plus 4 over 3 multiplied by 2 plus 2. The numerator equals 12 Also the denominator equals 12. 12 over 12, the final result equals 1. Another example. Limit when x tends to 2 of the function 5x minus 10 over 4x minus 8. Here by direct substitution with the value of x which equals 2 multiplied by 5 minus 10 over 4 multiplied by 2 minus 8, the result will be 0 over 0. This algebraic fraction function has a limit, but you should simplify it to its simplest form to find this limit. Take care. The numerator has 5 as a common factor. You can take 5 as a common factor, 5. Then the remainder here is x. Negative 10 divided 5 equals negative 2. The denominator has 4 as a common factor, 4. The remainder is x, and the negative 8 divided 4 equals negative 2. I'll cancel x minus 2 and x minus 2. Then the value of limit equals 5 over 4. Here are the steps again. Then I'll cancel x minus 2 and x minus 2, and the remainder equals 5 over 4. Another example, limit when x tends to 4 of the algebraic fraction 2x minus 8 over x squared minus x minus 12. The first step by substitution with the value of x equals 4, the result equals 0 over 0. So we should factorize both numerator and denominator to put this algebraic fraction in the simplest form. To simplify the numerator, take 2 as a common factor because both numbers 2 and 8 are divisible by 2. Then the remainder x, here's the remainder negative 8 divided 2 equals negative 4. And the denominator x squared minus x minus 12, here is x. By using your calculator, move equation number 3, a equals 1, b equals negative 1, and c equals negative 12. Then the two brackets are 4 and 3. Here is the sign is negative 4 and here is positive 3. The two values given by your calculator are negative 3, and it should be written as positive 3, positive 4, and it should be written as negative 4. Then I'll cancel x minus 4, the remainder 2 over x plus 3 to get the limit of this function. Therefore, the limit when x tends to 4 equals 2 over 4 plus 3 equals 2 over 7. You can see these steps again. Another example, limit when x tends to 2 of the algebraic expression x squared minus 2x over x squared minus x minus 2. For the numerator, we can take x as a common factor, x squared minus 2x. Here, x is repeated in both terms, the first term and the second term. We can take x with the smallest power, which is x power 1. I can take x as a common factor, and the remainder is x minus 2. By the same method, as we said before, x squared minus x minus 2 can be factorized into x minus 2 and x plus 1. I'll cancel x minus 2 and x minus 2. The remainder here is x over x plus 1. Therefore, the value of the limit when x tends to 2 equals 2 over 2 plus 1 equals 2 over 3. Again, the steps are, firstly, you should cancel x minus 2 with x minus 2, and the remainder will be x over x plus 1, and the final result of the limit equals 2 over 3. Another example, limit when x tends to 9 of 9 minus x over x squared minus 81. 9 minus x can be written as negative the bracket of x minus 9. The denominator here is a difference between two squares, and it can be factorized into two brackets. The square root of x power 2 is x and x. The square root of 81, 9. The first bracket sign is positive and the second bracket sign is negative, and then I'll cancel x minus 9 with x minus 9. The remainder here is negative 1 over x plus 9. Therefore, the value of the limit when x tends to 9 equals negative 1 over 9 plus 9 equals negative 1 over 18. Again, your steps negative 1 over x plus 9 is the remainder, and substitute by the value of x which equals 9, then the limit equals negative 1 over 18. Another example, limit when x tends to 0 of x plus 2 power 2 minus 4 over x squared plus x. Firstly, x plus 2 power 2 can be written as a perfect square trinomial. X power 2 plus first multiply second multiply 2, which equals 4x plus 4. Here, the numerator, the bracket x plus 2 raised to power 2 can be written as the trinomial perfect square trinomial x power 2 plus 2 power 2, which equals 4, and the middle term equals first, which is x, multiplied by second, which is 2, multiplied by 2, x multiplied by 2, 2x multiplied by 2 equals positive 4x, minus 4, over x squared plus x. I'll cancel 4 and the negative 4. Here the remainder is x power 2 plus 4x, and you should take x as a common factor. X, the remainder is x plus 4, over x squared plus x. You should take x also as a common factor, x, and the remainder is x plus 1. I'll cancel x with x. The remainder here is x plus 4 over x plus 1. Therefore, the limit when x tends to 0, substitute by the value of x which equals to 0 in this fraction, 0 plus 4 over 0 plus 1, then the limit equals 4 over 1, which equals 4. You can see also these steps again. Factorize x squared plus 4x to be x multiplied by x plus 4, and the denominator x squared plus x should be factorized by taking x as a common factor to be x multiplied by x plus 1. X is cancelled and the remainder x plus 4 over x plus 1, then the final result equals 4 by substituting with the value of x which equals 0. Another solution, we can treat with the with the numerator as a difference between two squares, x plus 2 power 2 minus 4. The square root of the first term, x plus 2 power 2, its square root is x plus 2. I write x plus 2 and x plus 2. The square root of 4 is 2 and 2. The sign of the first bracket is negative and the second bracket is positive. Then I'll cancel 2 and negative 2, then the remainder is x. And the second bracket equals x plus 4 over x and x plus 1 as we did it before. I'll cancel x, then x plus 4 over x plus 1. To get the limit, substitute by the value of x, which equals 0. 0 plus 4 over 0 plus 1, then the final result equals 4. Here are your steps again. After we simplify this expression, the remainder is x plus 4 over x plus 1, and the value of the limit equals 4. Another example, limit when x tends to negative 2 of x plus 2 over x power 4 minus 16. The denominator here, x power 4 minus 16, is a difference between two squares. It can be factorized into the square root of x power 4 is x squared. The square root of 16 equals 4. Here is negative, also here is positive. And the numerator is x plus 2. This expression can be factorized again. X squared minus 4 is x minus 2 and x plus 2. This expression has no factorization, x power 2 plus 4. I'll cancel x plus 2 and x plus 2. 1 over x minus 2 is the remainder. Then to get the limit, substitute by the value of x, which equals negative 2 here. 1 over negative 2 minus 2 multiplied by negative 2 power 2 plus 4. And the limit here equals negative 1 over 32. Okay. You can see also these steps again. Another example, limit when x tends to 9 of x plus root x minus 12 over x minus 9. The numerator here can be treated as a trinomial. You can factorize it by first step. You should change x and write it as square root of x raised to power 2. Square root of x raised to power 2, this value equals x. Then the trinomial is root x power 2 plus root x minus 12 over x here can be written as square root x raised to power 2. The numerator can be factorized to square root of x and the square root of x by using your calculator. Mood equation number 3, a equals 1, b equals 1, and c equals negative 12. A equals 1, b equals 1, and c equals negative 12. The results given by your calculator is 3, and it can be written as negative 3, negative 4, and can be written as positive 4. The two brackets are root x minus 3 and root x plus 4. Here the denominator is the square root of x power 2 minus 9. It can be factorized into square root of x minus 3 and square root of x plus 3. I'll cancel x, root x minus 3 and root x minus 3. The remainder is root x plus 4 over root x plus 3. Then, to get the value of the limit, substitute by the value of x to be square root of 9 plus 4 over square root of 9 plus 3. Here, the numerator is 7 and the denominator equals 6. Another example. Limit when x tends to 1 over x minus 1 minus 3 over x power 3 minus 1. To find this limit, you should simplify the given algebraic expression. Here, one over x minus 1 minus 3 over x power 3 minus 1. The first fraction is written in the simplest form, and the second one, you should factorize the denominator x power 3 minus 1 to be x minus 1, and the large bracket equals x power 2 and 1 power 2, which equals a positive 1. You should change this sign of negative to be positive, and x multiplied by 1 is x. Then, you should make a common denominator, which is x minus 1 and x power 2 plus x plus 1. The first fraction is x squared plus x plus 1, and the second fraction numerator is negative 3. Then the remainder here is x power 2 plus x minus 2 over x minus 1 and x squared plus x plus 1. The numerator here is a trinomial. By using the calculator, mode equation number 3, a equals 1 and b equals 1 and c equals negative 2. Therefore, this trinomial can be factorized into x minus 1 and x plus 2 over x minus 1 and x squared plus x plus 1. I'll cancel x minus 1. The remainder is x plus 2 over x squared plus x plus 1. To get the limit, substitute by the value of x, which equals 1. Then 1 plus 2 over 1 power 2 plus 1 plus 1. Then the numerator equals 3 and the denominator 3. 3 over 3. The final result of the limit equals 1. Here are your steps again. After we simplify this expression, the final expression is x plus 2 over x squared plus x plus 1. Then substitute by x equals 1 and the final result of the limit equals 1. Another example, it is required to find the limit when x tends to 4 of x power 3 minus 15x minus 4 over x minus 4. To simplify the numerator expression, which equals x power 3 minus 15x minus 4, you should use long division. How can we use long division to simplify this expression? We can use a method of long division. Here is 4. The expression x power 3 minus 15x minus 4, I write the coefficient of each term. X power 3, its coefficient is 1. X power 2 doesn't exist, then I write 0. X, its coefficient is negative 15. And the free term here is negative 4. You should write 0, then add 1 plus 0 equals 1. 1 multiplied by 4 equals 4. 0 plus 4 equals 4. And 4 multiplied by 4 equals 16. Negative 15 plus 16 equals 1. And 1 multiplied by 4 equals 4. Negative 4 plus 4 equals 0. This method should end with 0. Then the expression can be written as positive 1, positive 4x, and the positive 1x power 2. And another small bracket contains x. Change the sign of this number to be negative 4 over x minus 4. I'll cancel x minus 4, then find the limit when x tends to 4 by substitution with the value of x. 4 power 2 plus 4 multiplied by 4 plus 1. Then the limit of this function equals 33. Here are the steps again. This is the long division, and we can use the other method. Another solution. Here are the coefficient of each term. 1 is the coefficient of x power 3, 0 the coefficient of x power 2, negative 15 the coefficient of x, and the free term negative 4. I write 0, 1 plus 0 equals 1, 1 multiplied by 4 equals 4, 0 plus 4 equals 4, and 4 multiplied by 4 equals 16, negative 15 plus 16 equals 1, 1 multiplied by 4 equals 4, negative 4 plus 4 equals 0. Then the numerator will be x minus 4, and the large bracket is x power 2 plus 4x plus 1 over x minus 4 by cancelling x minus 4. The remainder is x power 2 plus 4x plus 1, and the value of the limit equals 33. Another example of limit when x tends to 4, x power 4 minus 21 x power 2 plus 20x over x minus 4. Here the numerator contains x as a common factor. Then you should take x as a common factor, and the remainder will be x power 3 minus 21x plus 20 over x minus 4. To simplify the expression of x power 3 minus 20x plus 20, to factorize it, you should use the idea of long division. I write the coefficient of x power 3 which equals 1. The coefficient of x power 2 doesn't exist, then its coefficient equals 0. The coefficient of x equals negative 21 and the free term equals 20. You should write here the same number of the limit, 4. And I write 0, 1 plus 0 equals 1, 1 times 4 equals 4, 0 plus 4 equals 4, and 4 multiplied by 4 equals 16, negative 21 plus 16 equals negative 5, negative 5 times 4 equals negative 20, and the 20 plus negative 20 equals 0. Again, I write here 4, the same number of the limit. The coefficient of each term in this expression is 1, 0, which is the coefficient of x power 2, which doesn't exist, and negative 21 and 20. Here is 0, then I'll add 1 plus 0 equals 1, 1 times 4 equals 4, 0 plus 4 equals 4, 4 multiplied by 4 equals 16. Negative 21 plus 16 is negative 5, and the negative 5 times 4 equals negative 20. 20 plus negative 20, this method should end with 0. Then the expression can be written as negative 5, positive 4x, and 1x power 2. And the small bracket is x minus 4. Don't forget to write the x, which was taken as a common factor. Here is x minus 4. I'll cancel x minus 4 and the remainder x power 2 plus 4x minus 5. Therefore, the limit when x tends to 4 equals 4 multiplied by, I'll substitute by the value of x, 4 times 4 minus 5, and here the limit equals and here the limit equals $17. Another example of limit when x tends to 9 of square root x minus 3 over x minus 9. To simplify this expression, any algebraic fraction contains a square root. You should multiply this expression by its conjugate. Then root x minus 3 over x minus 9 should be multiplied by the conjugate of the denominator, which contains the square root. Then square root of x plus 3 over square root of x plus 3. Then the numerator will be square root of x times the square root of x, which equals x. Negative 3 multiplied by 3 equals negative 9. And the denominator here is x minus 9 multiplied by root x plus 3. Then I'll cancel x minus 9 and x minus 9. The remainder is 1 over root x plus 3, and the limit equals, by the direct substitution of x, root 9 plus 3, which equals 1 over 6. You can see all these steps again. Okay. Another solution here. We can put the denominator as a difference between two squares. X can be written as square root of x power 2 minus 9. Then the numerator is root x minus 3, and square root of x power 2 minus 9 can be written as a difference between two squares, root x minus 3 and root x plus 3. This is multiply. I'll cancel root x minus 3 and root x minus 3. The remainder is 1 over root x plus 3, which equals 1 over 3 plus 3 equals 1 over 6. Another example, limit when x tends to 5 of root x minus 1 minus 2 over x minus 5. Here, to simplify this expression, you should multiply the expression contains square root by its conjugate. Root x minus 1 minus 2 multiplied by its conjugate, which is root x minus 1 plus 2, over x minus 5 multiplied by root x minus 1 plus 2. Then the numerator will be square root of x minus 1 multiplied by itself. It will be x minus 1. Negative 2 times positive 2 equals a negative 4 over x minus 5 multiplied by root x minus 1 plus 2. Here is square root x minus 1. Then the numerator x minus 1 minus 4, which equals x minus 5, will be cancelled by x minus 5. And the remainder is 1 over root x minus 1 plus 2. Then substitute by the value of x, which equals 5. 5 minus 1 plus 2. Here 5 minus 1 equals 4, and the square root 4 equals 2. 1 over 2 plus 2 equals 1 over 4, and this is the final result of the limit. Again, you can see these steps. The final result will be 1 over 4. Today's lesson, which is called the limit of the algebraic of the function at a point. This lesson is given for scientific section and also for arts section. Thank you.